Hi, everyone. Welcome to our seminar on debunking myths of LLMs. Just as a note, our webinar is being recorded and will be shared with everyone who registered after the webinar. In terms of our agenda, we'll have about 45 minutes of discussion or so, although it looks like it's going to be a little shorter due to some unforeseen circumstances. We have one panelist here. And then after the discussion, we'll have a short Q&A section. You can submit your questions for Q&A at the bottom of the screen where it aptly says Q&A. And yeah, so then we can get started. So I'll introduce myself. My name is Claudia Siegenthaler, and I'm a project manager here at Intento on our customer implementation team. And I've been with the company for just over a year. And have really enjoyed immersing myself in this localization tech space. And I'm based in San Francisco. And I'd like to thank Grigory for being here and taking time out of his day for him talking and sharing his information about LLMs. And so I'll pass it to Grigory to introduce himself.
Hi, everyone. I'm Grigory. I'm CTO and co-founder of Intento. I'm also Google developer expert in machine learning and AI, and I also have a Ph.D. in AI. So I frequently read all the new papers, and I'm excited by the field. So I'm happy to share all the news we have since the last webinar and all the interesting details we can discuss today. Unfortunately, Andrzej did not join us at the moment. Maybe he will join, but if not, we're still ready to discuss what we have, and maybe we'll have just more time for your questions.
Yeah, exactly. Perfect. Thank you so much, Grigory. So like you mentioned from last time you spoke, is anything worth mentioning? Are there anything new and exciting that you've seen since last talking on this topic?
Oh, yes, I think the field changed almost completely since our last webinar. You likely heard about DeepSeek. You likely heard about new models by OpenAI, like all three models. And Google also published their new models. And right now, it looks like Cambrian explosion of models again, not the first time, but still. So to summarize briefly what happened and what's really important, I'd start with DeepSeek. It's really big news. So DeepSeek is a Chinese company which created and trained their own large language models and published them. There are at least two models, DeepSeek V3 and DeepSeek R1. They're different. DeepSeek V3 is a general chat model, something like GPT-4o. It's a model trained to continue chats. It can be instructed. It's trained the ordinary way. You just prepare a lot of training data and train the model on this data, and the quality of the model is pretty good. It's a big model, and what's important, it's open. It's completely open. No, not completely. It's the model is published, and it's published under permissive license. Code is not published, and data is not published as well. So in these terms, it's not 100% open, but still you can download it. You can run it on your own and use it in any settings you want. The only problem is, as I said, the model is pretty big, and in order to run it, you need a really big GPU configuration. It's pretty expensive. It will require 8 to 16 large expensive GPU cards like H100 or H200. But that's a really big opportunity. And that was the first model by DeepSeek. It was published in December, and in January they published another model called R1. It is trained, it's based on V3, but there are several important additions. First, it was trained in a different way using reinforcement learning. It's It's not a new technique, it's a pretty old technique, but I'd say this is the first time reinforcement learning really works on such a large scale. Previously, reinforcement learning was limited only either for small scale models or for very special settings like reinforcement learning from human feedback, RLHF. But here it was different. Here they used reinforcement learning to train model to reason. In this sense, this model is similar to OpenAI's O1 or O3 type of models. And reasoning models is really a new beast in our zoo. Right now, in what terms these models are different from the ordinary models like GPT-4o? These models do not provide answers directly. First, when you ask some question from the model spends some time for doing internal thinking. It is called chain of thought or something like that. So the model tries to break the task into simple steps and thinking step by step. And this process sometimes hidden. For example, O1 models from OpenAI usually do not show what they think internally. But then after the model is done with this step, the model is ready to generate the answer, and it generates the final answer, and that's it. Why is it a big thing, and why is it a game changer? Just because we as a humanity, as a AI companies who develop these models, we found a new way to scale the models. It means that if you allow the model to think longer, to make this internal thinking longer, the quality of the answer is typically better. And OpenAI shows a lot of graphs showing exactly that. When you allow the model to generate more tokens in their internal thinking, the quality of the final result can be significantly better. And OpenAI reported that this way they almost solved a really, really hard AI benchmark called ArcAGI. Previously, previous attempts didn't achieve such high scores like OpenAI's O3 model. So this is a really, really good thing. And right now, with all these reasoning models or thinking models, you can spend your money and your compute in a different way. Previously, you only was able to just train model longer, but right now with an already trained model, you can run this model for longer, let it think longer, and then produce a better result. So that's a really, really big thing. And the DeepSeek R1, the reasoning model from DeepSeek, is also open. You can download it, you can run it. Again, it will require significant investments in terms of hardware, GPU, and if you want to run it locally, it likely requires some technical talent to run all the engineering stuff. But that's a good way. Now at least you have an option. Not only closed model from OpenAI, but some other model which might be good for your tasks. But again, it's important to test the model on your data with all these different models available from the shelf, which you can download and use, or you can use from API. There is a problem. There are general benchmarks. You can kind of compare model on these general benchmarks, but that doesn't really answer your question. For example, if you need some specific tasks like translation or some specific post-processing, you need to test the model on your data. The quality may be very different from the general benchmarks. That's a really important thing, and do not rely on these marketing public benchmarks. They may be good. The model may be really good in some particular domain, for example, mathematical tasks, but it might be not as good on multilingual tasks. And with DeepSeek, there is another thing. The model was originally trained mostly on English and Chinese data with some additional mix of other languages. And it's hard to say what are other languages and what is the composition of the data set because it is not described in the original publication. That's one more reason to test on your data, especially if your tasks involved not English and not Chinese data. And we, as Intento, right now preparing some update to our report. First, of course, we are preparing big machine translation report we'll publish in this year. But before that, we will do some small investigation on how these new models behave on tasks we face with in real life settings with real life clients. And we hope to publish this small research soon, hopefully next week. And OpenAI new models and DeepSeek models will be here. So that's one big significant thing which happened since the last webinar. And I'd add two more smaller things. One I already mentioned is that OpenAI published their new model called O3. Right now, O3 Mini is available. It's again a reasoning model. You can use it, and Mini typically means a smaller but faster model. And smaller typically means a model with lower quality than a large model. So again, it's hard to compare it directly to O1 or some other models. Again, you have to try it yourself on your task and your data. But there is a good option, and on some benchmarks, it really shines. So it's a good addition. And Google also recently updated the lineage of Gemini models, and right now there are new Gemini 2.0 Flash in general availability. There are Gemini Flash Lite. There is also experimental models, Gemini 2.0 experimental, and there is a reasoning model from Google. Again, in experimental, it's called Gemini Flash Experimental, I think, and it's kind of preview mode. It's not ready for it's not in general availability, but you can use it. You can experiment with it, and if for some specific task reasoning is important, that makes sense to try. So I'd say that that's the main big news since our last webinar. If you are really interested in the details of DeepSeek, find me on LinkedIn. I just published a series of blog posts describing the high-level picture of why DeepSeek is important and much more details on the technical side. If you want and like to dive deeper and understand what are the architectural innovations by DeepSeek, you'll find it there. Or of course, you can read the original paper if you want. And by the way, I highly recommend, if you are a technical person, I highly recommend reading these papers because they're good. So that's the short update on what changed since our last webinar.
That's great. Thank you, Grigory. And I'm excited to read our State of MT report too, that comes out every year. I had some various people in the industry ask about that. So I'm happy that should come out soon. So you mentioned that LLMs, there's a lot of things obviously that go into it. And one big component, of course, is cost kind of landscape and the complicated cost landscape for commercial LLMs. So wondering if you can talk more about this specific topic.
Yes, that's a really big topic. Actually, we originally planned to discuss it in the previous webinar, but we had no time for that, so we kept it for this time. And I prepared the slide for that, just to highlight the. Can you see it?
There we go. Yep, it pulled up.
You can see it. Okay. Here it's a not end-to-end recipe on how to calculate costs. It's just a slide to highlight that there are multiple dimensions in terms of cost. And here I'm talking only about commercial LLMs with their API for which you have to pay. A separate topic is the costs related to like total cost of ownership if you run open source LLMs locally. We'll touch this topic later. Right now, only about commercial. And I want to highlight many things, actually. with the traditional machine translation, traditional MT, everything was pretty simple. You pay for input characters, and that's it. There is a very simple price. There is a very simple way to calculate or to estimate how much will you spend. You just calculate how many characters there were in the original data. You call the translation API and you get result, and everything is simple. Okay, there were some complications, like you can train custom models, and custom models typically cost more than base models, but okay, that's a simple thing, and that's only one thing. Oh, great! I see Andrzej joined us. It's perfect. So we'll discuss the next topics with Andrzej. So let me finish with this slide, and we'll switch to more interesting two-person discussions. So yeah, with MT, everything was pretty simple. You pay for characters, and that's it. With LLM, it starts to be complicated since the beginning. First of all, you pay not for characters, but for tokens. And for most people, it's really hard to understand what does it mean, tokens, and how many tokens are in the text you send to the LLM. It's not so easy, and the worst is that different languages split into tokens very differently. For example, for English, you may have one or maybe two tokens in a typical word, but for, I don't know, for Hindi or for Chinese or for other languages, you may have number of tokens, sometimes even more than number of characters in the original sentence. So that's a big difference, and you have actually effectively you have different pricing for different languages. That's a problem, but that's only the beginning of the problem, because next dimension of this complex pricing is input and output tokens have different prices. So first, you can predict how much will you pay for the data you send to the model, but after model starts generating, you actually don't know how long the generation will be and how much will you pay as the result. Okay, you can limit the number of tokens the model will generate, but that may not work for your case because the sentence may be abrupted. So that's a problem. Well, that's an additional complication. Again, not the only one. You can train, fine-tune models and get custom models. And for custom models, pricing is different again. And last year, a new type of models emerged, models with really long context, typically more than 128,000 tokens. And there is another split in pricing. There is one price for the number of tokens before that limit, and another price typically higher for the amount of tokens after that limit. Plus, given these models with large context, you now have an option to cache the input, because if you need to run subsequent queries with the same data, typically you pay for each run. It may be pretty costly with the long context, so it's good you have a way to cache this long input and pay less for cached input. But first, you have another dimension pricing, and then second, you have to control this caching process. Again, it requires some thinking. It's not easy to understand, and sometimes it depends on the vendor. You may need to pay for storage for this cached data. Again, another complication. Plus, there is separate pricing for multimodal LLMs. Most LLMs right now not only consume text, but can process audio data, images, sometimes video. And for these new modalities, the pricing is also different. So if you process this data, these types of data, you have to adjust your pricing. And now there is a recent complication with all these reasoning models, which do some internal thinking, internal reasoning. You have to pay for the internal reasoning is actually the same tokens. The model just generates text, but this part of text, the internal thinking, is some kind of internal machinery and some means to get the final result. But the model still consumes some computation for that. The model requires hardware resources for that, and someone have to pay for this thing, and obviously it's the user. And the more the longer model thinks internally, the more you have to pay for that. And it's especially complicated for OpenAI, because OpenAI originally hid this thinking process. And when you get the result, you just know that the model thought and spent some tokens. You don't know for what exactly the model spent that tokens. You just have to pay for some additional number of tokens, and it's almost impossible to predict in advance how much will you pay. So that's another complication. And the last thing, many vendors implemented what they called batch calls. It's a way to optimize your costs if you need to process large amounts of data. So you may organize the workload in terms of large batch of data, send it to the vendor, and vendor will process it not in real time, but like asynchronous job, and then it will return the results. It will be cheaper, but again, if you use it, you have to adjust your calculations just to better estimate your costs. So that's it with the pricing landscape. You see there are many new dimensions, and it's really getting complicated just to understand how much will you pay for your tasks, especially that some things here, you almost have no influence on that. You don't know how long the model will think. You don't know how long will be the answer. You can only estimate that, but something could go wrong. That's the world we live in right now. Pretty complicated, but not interesting. So I'll stop here with this slide. Welcome, Andrzej.
Thank you.
Thank you, Grigory. Thank you, Claudia. Yes, apologies, I'm slightly late.
Not a problem. We're happy that you joined.
Okay.
I don't know if you want to give a quick introduction on yourself.
Okay, so I'm Andrzej Zydroń, co-founder and CIO of XTM International. So I've been basically torturing bits and bytes for over 50 years. So that's my length of time in IT. And over 35 years in localization from the computational point of view. So I've worked for Xerox, where I spent 18 years, which is longer than you get for murdering someone in the UK, by and large. 6 years at Ford, a very good stint at Oxford University Press, and obviously at XTM International, which I founded with Bob Willans 25 years ago, almost. So I have a certain insight into localization, and I've been really involved with large language models and computational linguistics in detail from the AI point of view for about 5 years. So I've been kind of reading the tea leaves and trying to work out what the hell this all means for us in the future. So I have some observations.
Yeah.
Yep.
Excellent. Thank you.
The thing is that it's still a boiling cauldron of creativity. Daily something new comes up. It's just incredible the pace at which things are going. To an extent, it's very reminiscent of the dot-com bubble, late 1990s, where really the internet, which had been kind of a low-level, low-grade academic, mainly environment, suddenly burst into the commercial world, where people realized what they could do with it. But I'll stop there. Claudia, back to you.
Yeah, no, thank you so much for those words and the great introduction. And I think now that you joined us, people are curious to know your response to this question. Grigory just shared his slide talking about the complicated cost landscape for commercial LLMs.
Yep, it's overcomplicated. It really is, compared to neural machine translation, or machine translation in general, where you paid according to source words, and that was easy. Now it's a bit of a quagmire. And the commercial companies actually justify this on the basis that that's how they're charged on CPU usage, or that's the closest they can get. And as Grigory quite rightly pointed out, there is a great disparity in terms of language, in terms of translation, in terms of language pairs, in terms of tokens, when you're going, say, from English, which, to be honest, is about 90% of all text that's translated is English source. Whether we like it or not, that's how it is. So English being the dominant language for tokenization LLMs, and the way in which tokenization works, it works off trigrams. So it's not words, it's the most popular three-letter combinations. Now, it's complicated a little bit by the fact that they're also the most common words in English. So if, but, and, over, all of the standard stop words, and then these trigraphs. And the closer, if you're doing translation, the closer the target language is to English. So if you take, say, French or Spanish, Italian, then there is reasonable equivalence in terms of tokens. There's not that much, maybe 1.5 times more output tokens. But when you move, say, to Russian, to Hebrew, or any language based on Cyrillic, the Greek alphabet, etc., move to Chinese, as Grigory pointed out, then one character can generate multiple tokens. So it's a bit of a difficult landscape there in terms of calculating costs. So if you translate using LLMs for translation, the costs from, say, English to French will be about a third of that, and say, or even a fifth of that than English to, say, Russian. So big difference there. So you have to take that into account. It's still quite cheap compared to neural machine translation. And still the standard LLMs are quite small. And I think Grigory has done some investigations on this. It can be up to 10 times slower. But if you're translating in batch, that's not an issue. But there is another aspect which I'll talk about later, which means that large language models can easily surpass neural machine translation, easily, equaling human level of translation. And that's astounding. But I'll stop there and we'll come back to this later on. So Claudia, back to you.
Thank you so much. That's great. I hope that gave people a better insight into that cost landscape with just the commercial LLMs. And Grigory, I liked your slide talking about, you can kind of have two models of maybe slower translation, a bit more expensive, and faster, but maybe not as high quality. So there's a little give and take with that. So moving on to our next question. I would love, Andrzej, we can start with you to discuss costs and the total cost of ownership for open and closed LLMs. And with that, would you mind starting by explaining what is the difference between an open and closed LLM?
Okay, closed LLMs are commercial LLMs that don't publish either their weights or any of the models. Open LLMs are completely open source. You can, if you want to, if you've got enough powerful hardware, you can download them and run them on your own hardware. So examples, obviously, of closed LLMs are ones from Gemini, from Google, especially Gemini 2, which is an excellent model. OpenAI's ChatGPT or GPT-4 series, now on O1 and O3. And most things from Anthropic, which is another really great system. Open ones are Mistral, DeepSeek, obviously, which is an incredible model with phenomenal output and speed. And it shows the benefits of sharing open source models. Most of the open source initiative was driven by Mistral and by Meta. So the models from Meta, Llama, first of all, 2, 3, 3.1, 3.3, these are really, really powerful models, and they get better with every iteration. The interesting thing is that there's kind of big push from Eric Schmidt, the ex-CEO of Sun Microsystems and then Google, and people like Elon Musk, etc., to just go open source with everything and then share all the benefits. Grigory made a very, very important distinction, which is between text-only models and omni models, which is what the O designation in OpenAI's GPT 4.0, 01, 03. So these are multimodal models, which are fantastic, but of almost zero relevance to us in terms of localization, except if you want to show it a menu in Chinese or Thai or Hebrew and get it to, which they do an excellent job of OCRing, to tell you what the equivalent in English is. They also are, and I've been doing experiments because I've started the Zoe system on the kind of Zoe diet. You just show it a meal, and I'm just astounded at how accurately it can detail all of the ingredients. It was phenomenal how accurate it can be. I've also asked it in Polish, and it returns absolutely all of the equivalents, the ingredients, everything in Polish, and also the cooking instructions, which is, it's getting frightening. These things are now escaping towards artificial general intelligence. I would say that in certain respects, we are moving very fast towards that. And the implications of that are quite profound. And then, Claudia, I'd like to mention what the implications are for software engineering programming with these models, because it's not just about language. They are getting incredibly good at programming. So back to you.
Awesome.
It's a topic I'd like to, if we have time, to expand on, because I think people will find this very interesting. So I can continue. Yes. I can continue on this thread.
Well, we'll go to Grigory and then later.
Grigory, over to you, because I've been hogging the microphone for too long.
No.
I want to highlight, I think, 2 points. First, with open source models, it's really interesting right now. Chinese open models tend to dominate the field. Among open models from the US, it was mostly only Llama by Meta. From Europe, it was Mistral. And now China has a set of very cool models. It's DeepSeek, of course, and it's also Alibaba Qwen family of model. It develops very quickly, and Qwen also have a reasoning model called QWQ. And Qwen continuously published new models, so it's really interesting to track, and definitely worth considering if you need to do something with Chinese and likely other Eastern languages. That's one point. And another point, returning to the total cost of ownership, I already touched that, but I still want to highlight that it may seem that having open model is very cheap and cost efficient to run, but there are a lot of costs hidden. First, you have to pay for the infrastructure, for the very pricey GPUs. And in order to use these GPUs efficiently, you need a constant workload so the GPUs do not waste their time without jobs. If your work is very uneven, for example, you have spikes and so on, you have to develop infrastructure that scales accordingly. So that's really important. So I see Andrzej wants to comment something.
I just wanted to comment, you can always use the GPUs for Bitcoin mining when you have spare time.
Oh, yeah, likely. That's a good business model, yeah. Okay, yeah, so that's one point. You have to pay for the infrastructure, and it may be pricey. And in addition to that, there is a labor cost, and it may be significant. You need an engineering team, and you need to optimize this model. You likely face issues with the stability, latency, some other issues, and you need your team needs to dive in and understand what they can optimize, what they can do better. So there will be, I don't know, GPU faults and some other things. You need to rerun your model. You need to redeploy them. There are a lot of things happening behind the curtain, and the good engineering team is very essential. And another thing is with vendors, you have some level of support. If something is wrong, you can rely that the company, OpenAI, Anthropic, Google, name it, will take care of that with time. With open model, you have to mostly to rely on yourself or on a community, and you cannot be sure that community, you aligned with community. Community may want to develop in one direction, but you may need some other things. And if open model does not provide such things, you have to develop it yourself, and that's another pricey thing. You have to hire LLM engineers, researchers. You have to compete with Meta and other companies for that researchers. So it's not easy to get top talent to work with things. And another, last but not least, there are, while the models are open, they are open in different way. There are now I only want to concentrate on licenses. There are licenses, there are open licenses, and not open licenses are the same. For example, there are good MIT license, there is and Apache 2.0, but there are other licenses, and you have to carefully read the terms. For example, Llama is published on the monopoly license, but it's still not as open as MIT, for example, because if I don't remember the exact wording, but I think if your company has more than, I don't know, some 100 million users, you have to additionally request permission from the Meta. Okay, that's problems nice to have, but still, it's not really open license just to take and use, and nobody cares. That's not that easy. So I stop here. My main point is that total cost of ownership may be really big for open models, and you have to consider all the dimensions and calculate for your particular case and your particular requirements what's important and what technical and infrastructure issues you may face with in future.
Yeah, that's a great point to end on. Thank you, Grigory and Andrzej. So we have about 5 more minutes to answer questions, so I'll give you this last one. So we've been talking for the past couple questions about cost, and so kind of switching over to security. And a question I know that people are wondering is, do commercial LLM vendors use your data to train their models? Who owns or even trains your data? And if you can touch on any concerns about data privacy with AI for maybe more sensitive work, that would be great. And Grigory, we'll start with you.
Okay, thank you. It's also a very multidimensional topic. First, I want to say that for most commercial vendors, there are no issues with data privacy, because all the major vendors explicitly say that they do not use your data to train their own models, but you still have to carefully read all the terms for any models you use. That's one thing, and another thing is there is a
That's Grigory.
We lost him. Okay, I think. Well,
Shall I pick that up?
yeah, please, as he's
Yeah.
joining back. Yeah.
Yep. As Grigory pointed out, commercial systems actually all come with an SLA, and if you pay, Grigory, you back? Sorry.
yeah, 21st century problems.
No, you carry on.
Yeah.
Yes. Yeah.
Nice to have you back.
Carry
when
on.
did you miss me on what phrase?
I'm just trying to remember. You basically saying that none of the commercial vendors will train on your data. We have there are full SLAs, etc.
Yeah.
If you pay.
Yeah, if you pay, most vendors do not use your data, but you have to carefully read the terms because, for example, DeepSeek is not that case. In DeepSeek terms, you can read that they may use. It's unclear how exactly, but that's why many people don't want to use DeepSeek API, and that's the problem. And also there are, how to say it, it's not a binary thing. They use your data or they do not use. There are multiple things here. Typically, almost all vendors do not use your data to train your models, but there is another thing, is how long the data resides on the servers. And some companies don't want their data even to reside on subservers anytime. So you have to opt out from that. Typically, OpenAI, I think, keeps the data for some time, maybe 30 days, I'm not sure. Again, you have to look at the terms. If you want to opt out of that, you have to write them emails and so on. And as I remember, when we started using OpenAI commercially, we wrote, I think, 3 different emails for 3 different opt-out things. And it's not easy to opt out from everything by a single action. Sometimes it requires some efforts. But still, data is almost surely protected. No one trains on your data except maybe very, how to say it, non-mainstream vendors. That's one topic. And another topic is indemnity. It's also important because many companies care about can anyone come and just sue them because the model generates something which infringes copyright and something else. And here it's also not a problem right now because all the major vendors, Anthropic, OpenAI, and Google, provide some indemnity. Here, some copyright shield or something like that. I don't remember how exactly it's called, but they say that if anyone comes and sue you as a company for these outputs of LLM, they take care of that and they spend their money and their lawyers to protect you. So that's good. In this sense, companies are protected. So I'd stop here and pass the word to Andrzej.
What else could I add? No, you've said it all, Grigory. It's a very comprehensive answer. I couldn't add really any more to that.
No worries.
Great. Thank you. Thank you. Yeah. So if you want to be okay, I'd add that okay, there are some still industries which require even more protection. For example, that the data must not leave data centers or servers by a particular company. Okay, for that cases, it may make sense to run some open models locally, or maybe use some private clouds, and some commercial vendors provides this support. You may use custom OpenAI models in your Azure data centers, for example. So that's there are ways to make the situation even more protected. So In short terms, I'd say everything is good with data protection if you use commercial LLMs.
Mhm.
That's a great note to end on there too.
Mhm.
Okay, so I think we're going to move into our Q&A section with the few minutes we have remaining. But before we move into Q&A, there will be a small pop-up on the screen for all the attendees. And if you could go ahead and answer these questions, it should only take a few seconds. All right. So I'll read, yeah, we got a few questions. And so I'll read the first one here. So the first question is, do data services like data curation, data cleaning, and data annotation still play an important role in enhancing LLM performance? What other data or AI activities should enterprises and their localization vendors be focused on? Andrzej, is
Should I
that
take it? Okay.
Please do,
It's one
yes.
of my favorite topics. Absolutely. If you're in terms of anonymization, data cleaning, all of these models will work much, much better if you just provide clean text. So if you have a markup of whatever nature in the text, it potentially will cause problems. So cleaning the data before you send it out for translation, then putting back any inline annotations is a good practice. You get much better results. That's true of any machine translation system. Anonymization is also maybe a requirement, legal requirement, depending on the type of data that's being processed. So if you're translating a legal document that involves some confidentiality where details are included of parties, addresses, names, telephone numbers, etc., obviously that needs to be taken into account. But having said that, one of the incredible benefits of large language models, which I've alluded to previously, is their ability to reach human quality levels. And how you do that? You do it using a technique called RAG, which is retrieval augmented generation. I think we discussed this on our previous panel a couple of weeks back. One of the fantastic benefits of large language models is that you can send them examples of previously translated text and ask it to translate it in this manner, or using a system called smart contexts in XTM. What you do, you can do effectively fuzzy completion, where a new sentence differs by, say, less than 70%. You can give it the example of the previous translation, source and translation, ask it to translate the new text in using the previous translation as a template. And this is something that NMT can't do. So if you build this into a interactive loop, so in your CAT tool, you are constantly writing to translation memory what's being translated, you can then actually use these previous translations in a dynamic way by sending them to the large language model as a template or an example of how to translate. So you get the voice, the terminology, everything that's required. So this is a big improvement in terms of quality. Now, these things can be automated, as I mentioned, so that you can, on the fly, just keep looking up and submitting previous examples, and this gives a big increase in terms of quality. So you're not translating out of context, because training a new model using your data is going to be very, very expensive. And we've tried it, the results aren't that good. But if you send it examples of previous translation, and if they're close enough, it will actually give you the same translations if a human being was translating it. It's a big problem with LLMs, if you're just using them for raw translation, is context. So if they don't know the prior context, then they'll just translate, without context. So they're typically translating on a sentence by sentence level, which is what most CAT tools translation systems do. So this is a big opportunity for the actual use of large language models. There are other benefits which if I can get a few minutes at the end to speak about, and these are to do with reasoning, with agents, and with generating code automatically. But I'll hand back to you now, Claudia.
Yeah, no worries. Can you, we have like a couple minutes, but a question that came up of this was then could we use TMs as templates?
Yep, you can.
Okay.
And you can do it via a system, very clever system. What you do, all of these large language models work off a system called embeddings. So the tokenization basically means that you convert the text into numbers. Effectively, these are weirdly geometric values of distance, and they're also give you the ability to do mathematics on tokens and sequences of tokens. So you can say, take the embedding for king, you can take away the embedding from man, so you do a subtraction, and you add the embedding for woman, you actually get the embedding for queen. Oddly enough, if you take the onomatopoeic woof woof, which is English for dog barking, and you take away dog and add cat, you get meow. So we're doing kind of clever cosine mathematics, trigonometric mathematics on the token. So you can actually write these embeddings into what's known as a vector store, which is a specialist database, which stores embeddings and text. And you can then query that with, so all your TM is then stored as a vector database. You then query that vector base with your new text, and you'll come up with the candidates in terms of meaning, not just in terms of surface form, but meaning. Because the great thing about embeddings is they go past surface forms, they embed meaning as well. So that's a big step forward with these models. And then, yes, you can use TMs as templates, or you use segments as templates that you take out of the TM. Otherwise, if you've got a TM that's got 100,000 words, 100,000 segments, that's going to cost you an awful lot if you pass that to the large language model every time you want to translate a sentence. Mind you, the new models have an incredible segment window. Previously, or context window. Previously, it was like 4K, 8K. Now it's gazillions of words, tokens that you can pass whole books in a prompt. Not that you would want to for cost purposes. So hopefully that answers the question.
I think so. Thank you so much. We're just about time. Grigory, I don't know if you have a very quick minute response, if you have anything to add.
No, it's maybe very short. With LLMs, it's much easier to use them for very complicated fields with a lot of requirements. And right now we see that quality is not a say, binary or even number thing, just from 0 to 1. Quality is very multi-dimensional thing, and there are many different requirements. And with LLMs, it's much easier to build a pipeline that satisfies different requirements. And we at Intento, for agentic approach, when different agents specialize on different parts of these requirements, because it's easier to do it this way than try to put everything in a single prompt or something like that. And because the LLMs are very, very flexible, it's a really game changer. Right now, you can solve problems you cannot previously solve with traditional MT. You can work with full text. You can easily implement glossaries by actually RAG. You can use TMs. You can use some other requirements for that. Previously, you had to hire people and instruct them. Right now, you can instruct LLMs and let people do much more and more complicated job with that. So yeah, I'm really happy that LLMs came, and I expect much more progress in the coming year.
Oh, 100%. Yeah, that's awesome. Well, with that, we'll end the webinar. So a huge thank you to Grigory and Andrzej for the insightful discussion and thoughts. I definitely know I learned a lot. And a big thank you too to XTM for collaborating with us to bring this to life. And thank you everyone who joined us today, asked questions. We hope you enjoyed it, and I hope that everyone has a great rest of their day or evening or wherever you are.
Thank you.
Thank you.
Thank you so much again.
Bye-bye. Bye-bye.